Get a problem from 1987 China CMO. The problem is not exactly the same. This is, I said, inspired by it. In the original problem, it says we have m distinct even number and n distinct odd number. They add up to 1987. That's the year of the exam. Of course, today is 2023, so I modify it a little bit. It doesn't change the essence of the problem or the methodology to find the solution. So we can treat it as the same, right? However, now we work with number 2023 here. You can, on your own, work out the number if it were 1987. Now, here, we want to find the max possible value of 3m plus 4n. Of course, you have to find it and prove that it is indeed the maximum possible value for m and n. So we try to find the bound for 3m plus 4n. Intuitively, we want to choose smaller number so that we maximize m and n here, right? So since they add up to 2023, so we can have this inequality here, right? 2023 would be greater or equal to the smallest possible m even number. That will be from 2, 4, 6, and so on and so forth, up to 2m, right? That's the first m even numbers, and the first n odd number would be 1, 3, 5, so on and so forth, and up to 2n minus 1. So if you do the sum, that's going to be, the first one is going to be m times n plus 1. And the second, for the odd number, we know that the first n odd number add up to n squared, perfect squares, n squared. All right, so here I would like to complete the square. Why? You're going to find out in a minute. So what we do here is m squared plus n. And in order to complete square, we have to add 1/4 to it. So what we have, this inequality here, we're going to add 1/4 on both sides. M plus 1/2 squared plus n squared. So we would like to derive an inequality with this term here, and we don't have it. So here we're going to use Schwarz inequality. The CS inequality here, this the sum of squares, and we have 3m and 4n here. We have m and n. So what we need to do is we're going to use coefficient here, 3 and 4, right? So we have 3 squared plus 4 squared. That's going to be greater or equal to 3 times n plus 1/2 plus 4 times n squared, right? That's CS inequality. All right, great. So by doing that, what we have is something close to 3m plus 4n, right? So let's combine these two inequality here, right? This inequality number 1, inequality number 2. When we combine that, what we have is 2023 plus 1/4 and times, this is 25, right? 3 squared plus 4 squared is 25, greater or equal to, this is 3m plus 4n plus, going to be 3/2, right? And square. 3m plus 4n is less or equal to square root of 2023 plus 1/4 times 25, and then minus here. All right. So this, when you do the math, is approximately 2 to 3.3 something, right? We don't care because we're dealing with integer, so which means we have the bound 3m plus 4n is at most 2 to 3 because there are integers. Now we find the bound. Now if we can argue that this bound is achievable, then the problem is solved. This is a common methodology where you want to find the max, you find the bound. If the bound is achievable, then you're done, right? Is this achievable? Now, intuitively, you want both even number and odd number to be small and they're close because the coefficient here is 3 and 4. So you want to have more odd number because it has factor of 4, right? So on the average, if you divide by 7, that's about 30. So you work around m and n, around number 30, right? And you want n to be slightly bigger. So let's try n equal, let's try different values here, right? Let's try m, let's try n. And we want to maintain the 3m plus 4n equal 2 to 3, right? And we want to track the value of the sum, right? The first smallest even number and odd numbers. Earlier we know that that's m times m plus 1 plus n squared. All right, so around 30, let's see. If n, let's say if this is a 31, that would bring this to 33. The total would be 2 to 3, right? But earlier we said we want to odd number, n is odd number here, right? We want n to be a little bit bigger, so maybe we forgot about that. So if you want to get it bigger, in the meantime, to maintain this equality, you have add n by 3, all right? So let's do that. Let's try 34 and 37. And this one, you're going to subtract by 4, right? So it's going to be 29 and 25, right? So let's try that. So in all the cases here, this remains 2 to 3, right? Because the way we manage m and n. Now, what is the value here? I use a calculator, okay? Supposedly you should use pen and papers. And this is 2083. This is 2026. And this is 2019. All right. So looks like this is too big, this is too big, this is too small. So does it mean that we cannot achieve this? Now remember, we chose the smallest possible, right? But it doesn't prevent us to change the number to be bigger, right? So we work with 2019, right? The difference is what? The target here. So we want 2023. So we need to add 4 to the number. All right, so which means add 4 to either of the numbers. That is, we claim that this is maximum, right? Is achievable with this. So this is we claim. We claim that m equal 25, right? N equal 37. So the first 25 even number would be what? Would be 2, 4, 6, up to what? Up to 50. And the odd number would be 1, 3, 5, and because 37, so that would be 73. But when you add everything up, is 2019. So we need to what? We need to add 4 to some number. That's easy. So for example, we can choose this to be 54. Then we're done. Or if you want, you can choose this to be 77, right? So in either case, we have achieved the maximum. And earlier, we used the inequality to argue that that's the bound, and the bound is indeed achievable with this value here, right? And the numbers are this. So this is a really interesting problem, and it tests on your math intuition skills in working with inequality and different bounds. All right, as I mentioned, try this problem with number 1987. This is the year of this exam. Hope you enjoyed the video. For these and other interesting math or computer science topics, please like, share, and subscribe to the channel.